All right. I'm ready when you are.
I am ready. I'll just make one note
Sure.
to the audience. Please put the questions in the Q&A. It's much easier to track than in the chat. So with that, let's go ahead and jump in.
Sounds great. Thank you, Carolyn, for that. So yeah, my name is Addison Higham. Today I'm going to talk to you a little bit about kind of our experience in deploying Apache Pulsar where I work at a company called Instructure. Normally I like to do these things. I like to speak and I like to do it in person to see people's faces and get to meet them, hopefully next year. But I'm totally fine if you want to leave questions in the Q&A throughout the presentation, and I'll try and get to them. So please feel free to interact with me that way, sans being able to see everybody's faces. Yeah, so a little bit about me. Once again, my name's Addison Higham. I'm a software architect at Instructure. I've been there for about 5.5 years. Feel free to follow me on GitHub or Twitter. I don't really use Twitter that much, maybe someday. So a little bit about today's agenda. As mentioned, kind of want to give a real quick overview of our whole process and dive in here and there to a few details of how we adopted and built out Pulsar. So specifically, kind of how we built consensus around Pulsar. I've seen a lot of questions in the community about, Pulsar relative to other solutions, and I want to share a little bit about how we viewed that and how we're also really able to get a lot of the company on board with that. Next, I'll talk a little bit about how we build our Pulsar cluster, some interesting details there that really helped us to do that quickly. How we continue to grow Pulsar at our company and really to foster adoption and build an ecosystem in our organization. And then finally, a bit more of a deep dive into one primary use case of how we're using many Pulsar features together to really make some things, do some interesting things. So up first, winning hearts and minds, really building consensus around Pulsar. In many ways, this has been the most challenging task of getting this whole thing done. Computers and whatnot, code, is pretty easy in some ways to make work and to get agreement around, but people are always going to be the harder challenge. And so we spent a lot of time of really trying to make sure that we had everybody on board and winning their hearts and minds to really make Pulsar successful. So to kind of frame that conversation, I'll tell you a little bit about Instructure. So Instructure writes a piece of software called Canvas, which is a learning management system. So if any of you, maybe if you have children, if you've been on a university recently, maybe you've heard of Canvas. It's quizzes, it's grade books, it's discussions, all these things that sort of facilitate online learning at institutions. We're a pretty large company at this point. We have 2 million concurrent active users, many more millions of total users. And we're pretty regularly in the Alexa Top 100. We serve a large amount of traffic and have some real things at scale. We're also an AWS company, primarily work on top of AWS, excuse me. So a lot of we're going to talk a lot about how do we leverage AWS with Pulsar in this. And we also use a lot of different tools and technologies inside AWS and languages as well, which has really sort of colored some of our of how we've gone and worked about with Pulsar. And we also have lots and lots of features. As a company, we have multiple different products, but also very wide products. Canvas has a lot of features, and so that's really shaped a lot of our sort of technical landscape as a company. So kind of to dig in, what are the problems? To kind of explain some of the problems that we had around messaging. One of the first things is purely just sprawl. I mean, I'm sure many of you have seen things like this as you begin to use microservices. We had multiple different messaging systems being used, primarily Kinesis and SQS, but some other ones in there. But probably more interestingly or more worryingly is that they were used pretty inconsistently. In some places where Kinesis was being used, it really would have been a better match towards SQS, and vice versa. In other places where we had historically been using SQS, as we grew in scale, Kinesis would have been a much better fit, but we're not. And Kinesis was, where a lot of things were moving, but as we continued to grow our usage of Kinesis, we started to run into a lot of feature gaps that really made it difficult for us to adopt or difficult to work with for all the needs we had of it. Primarily, the gap of long-term retention longer than a week, and it being increasingly difficult to get ordering at large scales. What I mean by that is, Kinesis has a relatively small shard size. And so for a lot of our use cases, we would need to do some ordering that simply wouldn't fit in a single shard. And so we would have to sort of reorder messages on the outside, which would be problematic and a lot more expensive. And then for SQS, SQS is a fairly simple piece of technology, but just without even being able to see more and more where we had use cases where we need to have sort of replay of messages. And with little to no ordering guarantees, it became less and less of a thing we could use. Beyond those gaps, we also started to see when projects used Kinesis, because of the nature of that really requiring us to work in a Lambda architecture, they would take longer to build. To give a little more insight into that, due to some of the long-term retention gaps, most of our systems using Kinesis would end up having like a fire hose going into S3, which would then have a batch system that would read that data, and then a sort of a speed layer, typical Lambda architecture. And what we continually found at these speed layer, batch layer, Lambda architectures were just very time consuming to develop and to maintain. And that really started to push us more towards a Kappa architecture as much as possible. In many ways, those architectures are still difficult to achieve regardless, but we want to move as much as possible in that direction. We also started to see large increases in cost with Kinesis. Kinesis is a really great product to get started with in the small scale, but as you increase usage, as we expected to, even more continued usage, it just began to be very expensive for the features we were getting out of it. And probably most interesting for our developers is just that it's pretty difficult. Kinesis is a pretty difficult system to use. Particularly the Kinesis consumer library, the KCL, only really works well within the JVM. We have a lot of languages that we support, Node, Go, Java, primarily Ruby is the main language. And really, the experience was much, much worse in any other language than the JVM. And therefore, most of use cases that used Lambda would end up being pushed toward, used Kinesis would be shifted towards Lambda, which has its own set of challenges. So as we started looking at these challenges, we began to really see what options were out there. And Pulsar attracted us pretty immediately, sort of my team and those who were looking at this problem. Excuse me. And some of the features some of the things we noticed is that in many of the cases with Kinesis, sort of log-like usage of messaging was actually like a secondary use case, or not even really a use case they were immediately worried about, but we needed it for either scale or for some potential use cases down the line. But most teams, the primary use case here and now was just to send and receive messages with sort of a PubSub API. But at the same time, we did have here and now use cases that really did require high throughput and order. And we really didn't want to have two systems. I mean, it's not an uncommon thing to see where, companies may run RabbitMQ for real-time, for more PubSub-based things, and Kafka as well for more log-based things. And we really didn't want to have to do that. And as we really dug into Pulsar's unified messaging model, we continue to be impressed that it's not just marketing, that it really provides the best of both worlds in being able to have a great slower or much easier learning curve to start using its messaging APIs, but it also really scales to some of these longer term log-based capabilities that are really powerful. The other thing that really attracted us as we looked at sort of the ecosystem around is we really didn't want to have too much management of any solution for various reasons, which the state of current vendor support for all these things, we felt we were likely to have to run our own. And so given that was the case, we really liked that Pulsar didn't really need to have us build a whole bunch or integrate a whole bunch of other tooling to do rebalancing, and that all of that was sort of built within Pulsar was very attractive to us. Another thing that we were very interested in was long-term retention. As I mentioned, we're really trying to move more towards a Kappa architecture, and the tiered storage was just such a great story to tell around that we could really do long-term retention for much cheaper. And then finally is, we're fairly large organization, lots of independent teams. The fact that multi-tenancy is built in and that we could just build on top of that for giving teams really sane access was very attractive. So that gives a lot of context. So we'll get into kind of how we sold Pulsar. And really, we kind of found three main sorts of talking points. And we spent a lot of time to understand the needs of the organization. And depending on which group of people we're talking to, we could sort of adapt these talking points or stress other ones. And really, we're able to explain to all the different parties involved what made Pulsar so attractive. And we really started to group those into three main talking points. So really from a capabilities perspective, Pulsar's got an incredible feature set. And being able to go to teams, engineers, and when they say, hey, I have this problem, this is something we want to do, to pretty much have an answer of within the Pulsar's feature set of how to do that. Second was cost, right? Both maintenance cost, long-term cost, but also development cost, of really being able to say that, Pulsar is architected and really designed, and a lot of thought has gone into making it run on top of Kubernetes. We really think that can speed up implementation, as well as some of its operational advantages. Really could help us make a good story around cost. And finally is ecosystem, right? Ultimately, these tools, such as Pulsar, they have a ton of value, but the real value that you can drive in your organization is to kind of build an ecosystem around it and be able to build it as sort of the backbone of being able to do things that you couldn't do before. And that was really what we focused on even more so than Pulsar is, hey, this gives us a really nice way with things like Pulsar IO and with some of integrations into how we do authentication and these other things to really make a compelling story around that instead of just, a technology. So talk a little bit about our plan that we went through this. One of the things that we found was really, in a lot of ways, our plan that was pretty much inspired by trying to do what you would do if you were trying to go build a startup, right? To really work iteratively and focus more on just we weren't going to commit to being able to hit, millions upon millions of messages right away, but really to show the MVPs of, hey, this is what we can do. Here's what these primary integration points of how you can get this into your application, and really focusing on figuring out how we could release quickly. And we had through many time period, near daily releases of sort of improvements of what we were doing on both the infrastructure side that was transparent to users, as well as lots of smaller releases on sort of the tooling integrations point that made that much easier. We really focused on making that a priority. Second was transparency. I think there's always a lot of risks in a lot of these things where you're trying to deploy a somewhat large technology. And we set some goals, and we very clearly spoke about those. We were going to initially focus much less on stability and saying like, hey, this isn't going to be something that from day one we want to throw all production load on, but instead we really want to build out the ecosystem and start showing how some of these smaller applications can get a lot of value right away. And that's not everybody's approach, but I think most important is that we were very transparent, repeatedly sort of said this is what our drivers were. And then finally is we really focused on adoption ecosystem. I'll talk about this a little more, but that was really our adoption was really our primary sort of a performance metric is how well this is being adopted, and really talking with teams to figure out what was preventing them from adopting it, what they needed to sort of be more serious about making Pulsar part of their application. Finally, we had to have a good logo. Everything, branding is everything. So this was something that a coworker of mine worked up. If any of you are 90s cartoons fan, the Magic School Bus, the message bus was just some fun that we had with it, and it helped get some laughs, and we enjoyed it. So anyway, I want to tell you a little about the results that we had through this whole thing. So we had this project sort of approved, and everybody was on board starting in May 2019. I didn't add that on here, but it took us about a month and a half to kind of do all that pre-work of kind of getting everybody involved and on board. And then we had our first MVP release on July 3rd, which was basically just Pulsar and a proof of concept for authentication. And then lots of other releases and whatnot happened here, but sort of our first beta we had done by July 17th. So very, very quickly we were able to sort of get a beta, something we felt comfortable for running internal applications, and with tooling that was a good example of how to get started. And then on November 20th of 2019, we had our first prod release to all 8 of the AWS regions where we operate. That included things like geo-replication, integration with our authentication service, which I'll talk about more. And since then, we were ready for some production load and have slowly seen that ramp up in the intervening time. Where today we have 4 applications in production with 4 to 5 more in development on Pulsar. We have heavy usage of Pulsar IO. We didn't expect that to take off as quick as it has, but we've had a lot of use of Pulsar IO as well as functions. That's really been a great feature. And we are up to about 50K messages a second for our largest cluster, and that's growing rapidly right now. We're really in the phase of sort of where a lot of our bigger applications are coming online about right now. That team has been composed primarily of 2 engineers full-time and then 2 other engineers who have sort of their efforts split across a few different projects. So it really also hasn't been an effort involving tons and tons of people. So I want to pause for a second and just ask if anybody has any questions. Yeah, if I do have some audio problems. Yeah, so somebody asked about if we're using Pulsar replications. Yes, we are. So we do use geo-replication. I'll talk about that a little bit in detail more later, but we do use geo-replication between each of those 8 regions. It has mostly gone okay. We've had a few issues here and there, but we don't have too many use cases where we're trying to message globally. In many ways, what we use geo-replication for is things like or the cases where we do use geo-replication for that, it's pretty low message volume. What we have used it a bit more for is for sort of like a disaster recovery of any messages we want to retain onto. We started with, another question is, we started with Pulsar 2.4.0, I want to say, early 2.4 release. And honestly, we've actually had custom patches throughout. We've had some issues, which I'll talk a little bit more about, but we've run that. We are not doing active replication, just geo-replication via the built-in replication. And we have some questions about hardware setup. I can talk a little bit more about that a little bit later. I'll kind of delay on that. And so another question about abstractions we've built over Pulsar. We really haven't built any abstractions over Pulsar. Our goal for our organization is mostly to just deliver Pulsar, but well integrated. Maybe the biggest thing there is just how we integrate with auth. Yep, and a question here about, so it took us about half a year to get everything up and running. That's correct. So that was kind of from first initial work to get also Kubernetes clusters deployed, which I'll talk a little bit more in just a second here, and to get everything up and running. So with that, I'll kind of move on to this next session of a little bit about how we did this. And so kind of as mentioned about abstractions, Pulsar is a very full-featured out of the box, and we really wanted to limit the amount of things we built around it. We wanted to offer Pulsar that was stable and well integrated into our ecosystem, so it was easy to onboard, but primarily, let Pulsar's features stand out there. Likewise, we wanted to use as much off-the-shelf tools as possible and really focus on the high-value glue to integrate it into our ecosystem of tools. And so what that means is that was one of the reasons we were able to deliver that so quick, is really focusing on those most critical bits. And then finally is a lot of iteration, a lot of and communicating about that iteration of, hey, we're trying something out here, either from an infrastructure perspective or whatnot. So one important part that really helped accelerate us is our usage of running Pulsar in Kubernetes. And what's most interesting about it is we actually didn't use Kubernetes. I mean, we had a few things here and there, but we really didn't have much to like Kubernetes clusters already in place. So that 6-month timeline also included kind of getting Kubernetes deployed. And part of the reason that was doable is because we bet on EKS, and that has worked out really well for us. That the EKS Pulsar on EKS would be much quicker than raw EC2, and it really helped. That seemed to be a good bet, and it's also helped us make the use of things like Pulsar Functions that have made them a lot easier for us to use. So a little bit of details about our Kubernetes cluster. We use Terraform using these modules right here, these Cloud Posse modules that were very high quality Terraform modules. And we run pretty simple EKS clusters. We use Datadog for metrics, FluentD for logs that go to Splunk. KIM is how we do per pod IAM. We use Certificate Manager to generate certificates both for our sort of services on top of Pulsar, like our authentication service, as well as for some of the Pulsar bits themselves. We use external DNS to point to our network load balancers that get created by Kubernetes. And we use Kate snapshots. This is just a small thing for taking snapshots of EBS volumes for our backups. We started with the Pulsar provided Helm charts, but we knew pretty quickly that we would, for our needs, particularly around georeplication, some of the other things we'd be doing, that we'd be making heavy customization of those. So we migrated them to customize. That's just a personal opinion, or just a personal thing we did. I don't necessarily recommend that, but worked well for us. We use EBS PIOps volume for Bookkeeper and GB2 for the ledger disks on Bookkeeper. I didn't put this here, but most of the JVMs we use for that 50K messages, right at the moment, we have, in our biggest cluster, we have like 5 or 6 brokers, and those are, I want to say, 3 or 4 gigs of heap, and then like 2 CPUs on like the newest generation of M5 instances. We use dedicated pools of compute for just for Pulsar, using node selectors and taints and whatnot, which really helps us sort of separate things out a little better. And a lot of the things are a lot of these things are tied together with a few bash cron jobs to kind of interact with our auth service and create secrets and these sorts of things. Just some sort of really quick bash glue. And that's one of the things that we found was so nice, was being able to just keep things in sync with a few lines of bash. As mentioned, we use Kate services with the NLB annotations to create network load balancers in AWS, as well as external DNS to expose them. So auth, I want to talk quickly about sort of what we did with auth here that I think isn't necessarily novel or groundbreaking, but really worked well for us. Once again, Pulsar is a very flexible system. You can implement your own authentication scheme. We opted to, as you might guess, to try and just sort of really focus on the high value things, is to build in the token, to use the token auth that's built in, and sort of supplementing that with a minimal small API that helped in generating tokens and sort of managing what we call role associations, which I'll talk about. Which sort of the core tenet, I guess the core idea of our authentication is we created a small API that lets you make an association between an AWS principal and a Pulsar role. And when you make that association, we drop credentials off into HashiCorp Vault, which is a technology we actually already did use, that only the AWS principal, in our case, most of the AWS roles, can access. So it's basically like a shared folder where access is controlled by Vault, such that only the role can pick it up. And it basically uses just some of the mechanisms of IAM principles and the unique IDs they have to create a location that's unique to that role. We wrote a small CLI tool called mbutil that just, instead of trying to like write a UI or anything, we just opted for a very simple CLI tool. And we implemented using gRPC, which really helped accelerate things for particularly the CLI tool. By using gRPC on the back end and then using being able to just generate most of the client, it made writing that CLI tool very quick and easy. So just to kind of give you an idea of some of the workflows that we developed, and I see some questions there, and I'll get to those in just a minute. I'll just kind of get through this next section here. The only manual step where our team has to get involved is just in the initial creation of a tenant. So when a new team wants to do something with Pulsar, wants to be integrated in the message bus, we kind of just have them create for us a JIRA ticket with an Okta group. We use Okta for authentication. And essentially then all that person has to do is sort of make sure that, this team isn't gonna, if we know that if they're gonna do a ton of traffic, that, we can prep for a little bit. But in most cases where teams are just getting started, pretty much it's just running a command with our message bus utility that creates a tenant for them and allows them and associates it with an Okta group. So just like we have it can associate an AWS principal, we also can associate our Okta groups with sort of a Pulsar role that allows us to generate credentials for users. So when that happens, so then a user, once that association has been made, they can use this MBUtil to log into the Pulsar API into a given server, given their tenant. And basically this just does pops a browser, does an OAuth workflow, takes them to a tiny, super simple website that we developed that gives them a JWT. And they copy and paste that JWT, and then they exchange that JWT for Pulsar tokens, and then we generate a configuration file for them. So the user out of this will get a little message that says, hey, export this environment variable that gives you a Pulsar client configuration file that Pulsar admin can use. I should have a demo of that, but I don't have one ready. So very simple workflow to just get somebody and say, hey, that's all we do, and then you just use the Pulsar admin, Pulsar client as usual. And then similarly, if somebody wants to associate one of these, like an application, so we differentiate users and applications. So we have a diagram for which may help clarify some of this. This allows you to associate an IAM role or an AWS IAM principal with a Pulsar role. So as I mentioned, the core thing that happens here is this generates a Pulsar JWT, a Pulsar token, writes it into a location in HashiCorp Vault with the name of the tenant, so in this case, my team, prefixed to the role that they requested. So by doing it this way, we give them, they can create any tokens for any roles underneath prefixed with their tenant. So it allows us to sort of namespace tokens. And then we just write that into that shared location in HashiCorp Vault. When a client, so in this case, a server wants to then get that token, we made MBUtil be, it's a very simple Golang binary. They simply, can download that, integrate that binary either via Docker image or however into their application, and they can run this command, which goes and talks to our Vault instances, logs them in, and then knows where to go fetch that credential that only it has access to, and then just grabs that out and gives them the token that they can use in their application. So that's pretty much what we put around Pulsar from an auth perspective. And as you can see, it's a pretty minimal. We haven't done super crazy deep integrations, but it's been sufficient enough that and easy enough to use, being that we piggyback off like AWS auth, that it's really worked well for our teams. So I'll take a second here just to look over these things. A few more questions here about running on K8s. I'll get to those in just a minute. So talking about some Pulsar functions, I will defer to these functions after a little bit of this networking bit, and then we can talk about that. So for internal communication, we use EKS networking, and we just basically use EKS and K8s. It's very straightforward for the internal networking. What's maybe more interesting is how we expose Pulsar to our customers, to other teams. So in our organization, we have lots of AWS accounts, each with their own VPCs. So we have a lot of different networks. And rather than using peering to associate networks together, we make use of VPC endpoints. So if you aren't familiar with this feature, that allows you to basically take a network load balancer in AWS and expose it in another account, in another VPC, in another VPC. So we don't expose any of our clusters on the public internet, nor do we have to do a ton of peering. Instead, we using these VPC endpoints, we can create a really simple, it's basically an ID that then they can have an association. They can request for that to be added into their VPC, and it essentially just kind of tunnels that network load balancer. And we use a similar technique for georeplication, but over peering. That doesn't work across regions, so we do peering there and then use those to communicate over that. Which we use Route 53 with private zones and external DNS, which I have a diagram here. So once again, quick overview of what we've talked about. Hopefully this will help clarify some of that. This is sort of a quick idea of how these flows work. So a human can use MBUtil over our VPN to hit our management API, they exchange that, and then they can interact with a proxy. And we have that all isolated to sort of one VPC. Other VPCs, like an application VPC here, gets that exposed via a Pulsar endpoint, and they'll use MBUtil to talk to Vault to fetch a token that they can then use to talk to our infrastructure. I'm running a bit low on time here, so I may, if there's questions about how we do our global Zookeeper, I can talk about that more in the Pulsar Summit channel. Happy to answer some questions. But essentially, we use peering between our different regions, and we use a combination of external DNS and Route 53 private zones to expose all of the components with stable names, and then just set them up to talk to each other. It's fairly straightforward, lots of NLBs and lots of Kate services to expose them. But we have had some, this is also how we run Global Zookeeper, to run Zookeeper across region. We've had some issues with that, so I don't necessarily recommend that, but that does allow us to run Global Zookeeper and make that work. All right, so what's worked? We've had great success. Clusters are easy to provision and scale up. We've had really sufficient performance even with relatively small VMs. EBS volumes being provisioned via Kate's persistent volumes have worked well for us. We've really had good success with those volumes properly being unmounted and remounted, and no real issues with corruption or anything along those lines. All the tooling in Kate's around managing certs and being able to kind of push them around with a few lines of bash has been really wonderful. And it's really allowed us to experiment much quicker. If we have an idea that we want to say, hey, maybe this will help us be more stable or be more performant, rather than having to write config management and Ansible and all these things, we've really been able to just use Terraform and Kates to experiment much quicker. And Pulsar function on Pulsar Functions plus Kates is really, the cluster auto scaling Kates is really, really great. So to talk a little bit more about that, since it was a question, we turn on the cluster autoscaler. So we have a pool of compute that we use that can be used for functions that responds to how many pods are being asked for. So when you want to deploy a Pulsar function, it will go and request a pod to be created. And if there's no compute there, the cluster autoscaler will notice that and then scale up the autoscaling group behind it. So essentially, we have, for Pulsar functions, we have very dynamic ability for people to go add a lot more functions, and we don't have to worry about it, nor does the team. And so that's been a really wonderful feature, is like, it took us a couple hours a day maybe to set up the cluster auto scaling. And then we already had Pulsar functions working, and now we have this very elastic pool of compute. But like, not everything has worked perfectly. So here's a quick list of maybe some issues that we've had. Some of these have been fixed, but just I'll share these slides. I don't have too much time to go over every single one of these, but we've had a lot of issues where Pulsar doesn't, and its components don't necessarily deal perfectly with the dynamic names and dynamic IPs of running on top of Kubernetes. For example, bookies getting rescheduled would cause the brokers would continue to use the old IP. There's some fixes coming, but one fix right now is to tweak the TCP keep alive so that those sockets get killed quicker. Brokers getting rescheduled, our proxies can get out of sync. I think this is a fairly well-known one, but has been fixed in the newest Helm deployments, but at the time wasn't as understood. Is to not use the Zookeeper discovery and instead use the API discovery. We also use deployments for brokers, or we don't use deployments for brokers, we use a stateful set. And for a while, sort of what most of this resulted in was we would have to, something would fail and we'd get in a weird state, and we'd have to use a manual, we use a manual restart. And another thing that really helped with that is using probes. In our case, and this isn't necessarily recommended for everybody, there's trade-offs in these things. We use a full health check to make sure that we can write a message to the brokers, and we do that both the proxies and the brokers. And if it's not working, that causes the brokers to restart, which may not be what you want, right? You may want to optimize for reads, but in our use case, that really helped us. That was more in lines with what we needed. The Pulsar proxy had a number of issues, many of which we fixed, but and is getting more stable, but it's wasn't necessarily totally battle hardened previously. And also, there's just not as much knowledge of people talking about large case deployments versus bare metal deployments. And so that was something that we whether that was docs or whatever, we had to do a fair bit of discovery. Zookeeper, especially global Zookeeper, that's probably been our most challenging thing, which I don't have too much time to talk to in this presentation. But and we also had lots of random bugs and admin commands. But I want to just circle back to this global Zookeeper is, that's us running across multiple regions. If you're not running across multiple regions, you wouldn't expect to see these issues. But those of you who may be looking to do geo-replication, feel free to ping me in Pulsar Summit. I can talk a little bit more about that. But the good news, right, is we started this 6 months ago, and even in that 6 months, the progress has been really rapid and really impressive. So the default Helm templates, most of the things that we talked about there, many of the things we talked about there, those are now included in the default Helm templates. And lessons that we learned and kind of the community was learning are now standard with if you're just going to use those Helm templates. There's also been a lot of bugs that, particularly around running on top of K8s, particularly running in kind of a more cloud-native environment, that made it less stable, have been fixed in the last 6 months. And we've contributed some of those, but there's also been a lot that have come from other places, and that's really rapidly improving. I mentioned the bugs in the admin command. This is just one of those things of like you get into weird timeouts and whatnot. Those are getting to be more and more rare, and lots of improvements are happening internally in Pulsar to make a lot more things be consistent. The docs are getting much better, and once again, the community's learning a lot, and there's really some more best practices that are starting to get established. And I think the best news about all of this is that really we've definitely seen this, and that there's really sort of this virtuous cycle of starting to happen of as adoption happens, we get lots of improvements from those new companies running Pulsar, which makes it easier to run, which makes adoption easier. And really in the last 6 months, that is very exciting to see how much progress Pulsar has made in being much more easier to adopt and bring on. So I want to get to a few questions here. So I think I talked a little bit about Pulsar functions and K8s. So how do we ensure no data loss? I'll give a short answer to that, and that we have like 3 different mechanisms of, obviously there's built-in replication to all the components, whether it's Bookkeeper or Zookeeper. We also use EBS snapshots. We also have geo-replication for DR purposes. And we also use that tool called K8 snapshots, which takes EBS, can take EBS snapshots, which we can restore in sort of a worst case. We haven't had a question here about maintaining Pulsar deployments. We haven't had any huge major challenges. We've had some downtimes in deploys that, particularly early on, is we've learned about how to make Pulsar be more resilient to dynamic names. Those have dropped and dropped and dropped. Now, most of the times when we push new releases of Pulsar, it goes quite smoothly. We only use Pulsar functions via the JVM right now. As far as there was a question about our usage of MBUtil and our API, our auth API, those are not open sourced. We currently don't have any plans for that because they're pretty tied into our ecosystem. But if you're an AWS shop, they may not be. So that's something you can we may be open to. We do not do we have one active cluster in each region? Yeah, so we have one Pulsar cluster in each of our regions, and there's only one cluster. We don't have like multiple clusters in each region. We don't. So somebody asked if how we get away with no Ansible. I would love to talk about that a little more. Feel free to ping me in the Pulsar Summit channel, but for interest of time, I'll defer that. And as I mentioned, there's some questions about ZK, global ZK. Please ask me that in Pulsar Summit. And do we have any challenge? Do we have any? There's a question about a Pulsar operator. I'm not as aware of. I know that is happening. I don't have any. I don't know much about that. And do you have any challenges in using end-to-end encryption? We don't. We just use the TLS that's built in. We don't use any of the other encryption on top of it. So not. If I can ask more questions about in the Pulsar Summit channel. All right. running a bit short on time here. Really appreciate all the questions, but I'll focus a little bit on just getting through this presentation. So continuing to build and grow. So as I mentioned, our next thing is really about adoption. That's really our, as I say here, adoption, that's our kind of KPI. It's what we've really been focused on. And once again, some of this idea of having the ecosystem around Pulsar, that's the real value to us organizationally. So I already talked about this. So this slide I think is, I forgot I had this. Pulsar Functions, by being able to have that hooked up to cluster auto scaling and have a really dynamic pool of compute, it gives us sort of a Lambda-like functionality that we have a lot more control over and whatnot. It's really been useful. And sources and sinks, because they tie into Pulsar Functions, that's really allowed us to migrate and onboard people. And one more thing I should mention here is one of the things we contributed to Pulsar was a per function runtime options. So you can write your own interface that will allow you to change how the functions pod gets run on your cluster. So that allows us to like isolate via a Pulsar tenant to a Kubernetes namespace. So then we can give teams access to poke around in that namespace and look at things and do some more sort of flexible things that's really helpful to our teams. Feel free to ask me more about that in the Pulsar Summit. As I mentioned, we've seen heavy use of sources and sinks. The Kinesis source and sink has really helped teams migrate from Kinesis because we can replicate a Kinesis stream into Pulsar, or we can replicate a Pulsar stream into Kinesis. It gives us a lot of options for teams to slowly transition between the two in a nice, smooth way. The same thing works for SQ and SNS. We just haven't had any of those happen yet, so we haven't done that one yet, but we expect to. And finally, change data capture. So the change data, the CDC connector that's based on Debezium, that's really the main big thing that will be the biggest driver of traffic for us. We have an internal version of that, which we hope to be able to contribute that we are in the process of getting to rolled out for about 60 plus, actually it'll probably be 100 plus database tables from 150 Postgres clusters. And actually it didn't account here for multi-tenancy. We'll have thousands and thousands of tables being replicated or using CDC to get into Pulsar. I'll talk a little bit more about that towards the end here, but it's also a very convenient way to kind of do an outbox pattern if you're trying to move more towards like a CQRS or evented style applications to be able to use that for an outbox. We also have a similar thing for DynamoDB. A coworker of mine just recently contributed DynamoDB Streams connector, which can be used for CDC if you use Dynamo. Another thing in the ecosystem that we're still in the process of really working on is Flink integration. Once you already have K8s and Zookeeper in place, there's really lots of great tooling for running Flink in HA. One of those is Lyft's Flink's K8s operator, and that really, in some of the early work we've done on this, we can start getting Flink jobs talking to Pulsar deployed very, very simply, not much setup, and we're able to reuse much of, and this is really where K8s is now paying extra dividends, is being able to run other things like Flink on top of the same infrastructure very easily. And this is where we really hope to see the most growth is really improving this story around Flink and Pulsar, because it gives you extremely powerful stream processing that can do real-time ETLs, replace Lambda architectures, and even some whole applications. So I mentioned I wanted to talk really quick about more of a concrete use case we have, and the biggest one that we've really been, a lot of the things have all been feeding into this, is building our real-time data lake, near real-time data lake. So this is something that I actually worked on many years ago at Instructure, and we do a very traditional do that a very traditional way with batch jobs. I'll talk a little bit, but as we've seen what Pulsar can do, it's really changed and made possible to say, okay, we think we can really bring down what right now has 24 hours of latency down to minutes of latency. And this is will be used internally as well as externally to deliver data extracts to customers, which we're very excited about. So currently, like many companies, the way we do that is with batch batch and speed layers for lower latency. And as I've kind of alluded to before, we found that very expensive and difficult to do Lambda architectures for all the things where we want to get low latency. And so, and it just, in some places, almost just incredibly difficult to do for some of the use cases we have with our data that really forces us to rebuild the world every day. We spend a lot of money on just recomputing, batch jobs because it's really difficult to make them be incremental. So where we're headed is using change data capture via Pulsar to get all this data into Pulsar, and then to be able to use Pulsar functions as well as Flink to be able to process them and route them properly. And then things like tiered storage, offloading, compaction allows us to keep all these, complete view of the table in Pulsar for really low cost and low operational overhead. And that from there we can then once again use these tools like Flink to build views, so to say, that we can then write to other places in near real time. So I'll just kind of work through this, and we can leave a few more minutes for questions. What we have found is that Pulsar is very compelling. Its set of features is unique among its competitors, and it's uniquely positioned in the marketplace to do a lot of things that requires a lot more tool. You have to build a lot more tooling around, Kinesis or Kafka or some of these other streaming solutions. And it may be less mature. It's true that it's less mature than some of these other solutions, but it's improving rapidly, and we've been very impressed with that improvement. And it has allowed us to have rapid iteration and deployment, particularly as it has native support for K8s. And it really, we think, helps lower the total cost of ownership and gives developers a much better experience through being able to use its PubSub API as opposed to a log-based API and whatnot. And as already mentioned, the Pulsar community is really a bright point among all this. Is it rapidly improves and delivers consistent new features and releases, and adoption continues to grow. I'm really excited to see that we were able to adopt it and that others are following suit, and it's a wonderful community as well. So we're very excited. We're happy to have adopted Pulsar and very excited for it. So I'll get to a few of the questions here. Sorry if I if I didn't get to yours. Please feel free to if there's any other questions.
Addison, we are just about up on time. If I can just add a reminder to the group that we do have all of the speakers on the Apache Pulsar Slack channel. So that would be a great way to reach out. Addison, are there any other channels that you'd prefer? Email, Twitter, what's your preferred channel?
The Pulsar Summit channel is a great for today, but I'm always in the Pulsar Slack, so feel free to reach out to me there if it's Kubernetes specific things, the Kubernetes channel. Those are all great places to reach me. So.